Recording is on.
Okay, can you guys see this one note, right? Awesome. So, um, here is the problem. First of all, perform transpose of the given matrix. So, we are going to discuss the 2D array problems. One is transpose, and the other one is diagonal printing in diagonal fashion. First one is transpose. Transpose means like given a matrix, and by n, or it's a square matrix. Let's make our things easy. We are giving the square matrix has been given. Rows should be become columns and columns should become rows. So it looks like easy one. Let's look at how to solve this. Okay, so I can give an example here. Here is the transpose. Yep. So 1 2 3, yeah, we can also draw here. I usually use this. Okay, let's go with this. So let's say we have a matrix like this square matrix, right? So let's put the 1 2 3 4 5 6 7 8 9. So this matrix has been given. We need to transpose this into like this. So rows, this row becomes a column. That means 1 2 3. Okay, this row become another column. 4 5 6. This row becomes another column. 7 8 9. Okay, so how are we going to do? So let's put the indexes as well, just for the sake of understanding. So always starts with 0 1 2, right? This is also 0 1 2. Have you anyone here hear this problem before?
Suresh, if we take a temporary array, we can do that using nested for loop.
Yes. So one simple thing is you can use temporary array. Basically, you can create another array and you can navigate,
Hmm.
right? You can navigate this way and you can put it this way. You can navigate this way. You can put it this way. But
Yes.
the condition here is don't use any extra memory. That is the
Okay.
how can we do this? Let's say it's because the problem is if you are taking extra memory, it's a you know it's for simple matrix it's okay. If I'm giving you really big, let's say you have 100k or 200k elements, right? Matrix is really big, geographical, let's say the Google Maps kind of matrix, where we don't want to take extra memory unless it is required. So how can we do this in the order of
We can swap A of ij with A of ji. We can do that. Order of n square it will take,
yeah,
but
order of n
we
square,
will not
that's
have extra memory.
exactly. There is no other
We
way. Order
can.
of n square is time complexity, because you
Uh,
definitely need to traverse every number. Yeah, it's yeah. Is that Tarun having issues? It looked like he's joining and leaving. Probably he may have some network issues. That's fine. So yeah. So basically, so what you said is you will exchange the numbers, isn't it? Right?
A of ij with A of ji. I mean, we'll take two nested for loops and we'll swap them. Swap A of ij with A of gi.
Yes, that's actually the solution. It is a simple one. So basically, what Arshad is saying is, I'm going to explain to others who is just trying to understand here. So basically, a of ij equal to, we can put a of j comma I. This is simple formula to solve this problem. What it is. So by looking at this matrix, you can easily try to understand here. So basically, what we're doing is we are exchange. So this will always be here. We are not changing it, and these two will be exchanged, right? Look at this. Like 2 came here, 4 came here, and similarly these will be exchanged. So if you have the other big matrix, these two will be exchanged like that. So we are exchanging the row cell value with the column cell value. So the 3 came here, 7 came here. Again, from here, right? See, 8 and 6, 6 and 8, and also 9 will be here, and 5 won't change, because the a and I are j, these three, if you look at carefully, these three are I and j are same, right? 0 0 1 1 and 2 2. This will be replaced with the same value. So that's why they are still there. The same formula will work for these three elements as well, but they don't go to the other cell because I and j are equal. Okay. Hey Tarun, do you have some network issues? Can you hear us? Can you hear properly? Everything is because you just joined
I
again.
just joined now only.
Okay, okay, okay. So you understood the problem, right? Basically, we want to transpose the matrix. Okay, rows becomes columns. So you see the output here. This is the output we want, right? So 1, 2, 3 becomes like 1, 2, 3 column. Okay, and four, five,
Yes,
six is
got
a
it.
4, 5, 6 is a row. Now 4, 5, 6 is a column here, right?
Hmm.
So 7, 8, 9 is the third row, became 7, 8, 9 as a column. Simple. So first
Got it.
solution, Arshad already told, we can take an extra matrix and we can copy each numbers. Usually, if you run the two loops, right, you will run like this: 1, 2, 3, 4, 5. Instead of that, you can run columns first. You can run these columns, like you can scan the numbers column wise and put it in the row wise. It's very simple if you have a separate matrix. But the question here is, don't use extra memory. So can we do in place? Basically, we need to just exchange the number in the given input. Okay, we should not use extra another space. Of course, we can use couple of variables I, j, k. You can use temporary variables if you want. Constant variables are fine, but we should not take another extra matrix. Okay.
Hmm.
So here is the simple formula to solve this problem. Arshad already shared this formula. Basically, what is the formula is, we need to take two loops and square. Basically, we can run either column wise or row wise. We can run column wise, just row wise as well. Let's say we will complete the first row, 1, 2, 3, 4, 5, 6. What we are going to do is we are going to exchange a of ij with a of ji. So basically, if you look at here, right, these two will be exchanged. So let's take what is the index for 2 here? A of
Zero comma.
0 comma 1, isn't it? So equal to a of, we are exchanging 1 comma 0. So what is the a of 0 comma 1 is 2, right? So 1 comma 0 is 4. Of course, we need to put it in a temporary variable. We should not override the value. So initially what we need to do is we need to take a temporary variable t equal to a of I comma j. So temporary, the swapping of two numbers, right? Very basic thing. When we learn programming, we usually have very basic thing of let's say v1 v2. You want to exchange the values. What we do, we'll take simple temporary variable, put the value of v1 in the temporary variable, and copy the value of v2 into the v1, and then take the t temporary variable value to the v2. This is very basic exchanging of the values, right? That's what we do here.
Yes.
So we take the temporary variable, we are copying the value of a of I comma j into temporary variable, then we are overwriting a of I comma j equal to a of j comma I. Basically, so for 1, 0, we are taking, so for 0, 1, this is a of 0, 1, we are taking 1, 0 value and we are putting here. Then a of j comma I equal to t. So whatever the value, temporary variable will come here. So these 4 and 2 will be replaced. Similarly, 7 and 3 will be replaced, and then 8 and 6 will be replaced. So it's kind of finding the exact value on the row and column. They will got replaced. Okay, that's how it is. Since it is a square matrix, it's easy. If it is a rectangle matrix, think about it. So we don't know how many columns. We don't know, like, even if you have 10 columns, like, it will be like this, right? So if it is rectangle, you may not find the exact value here, right? Only that's a difficult problem to solve. And we cannot even, like, we don't have extra memory. We don't, let's say if we have really big matrix and only have values for certain values here, then you need to identify, what is the boundaries, right? It's very tough in the rectangle matrix. It is very tough because you need to have the space. You need to change that matrix into this way, right? If it is a matrix like this, it will be changed, it should be changed to this way. But we need to have the space in the matrix, right? So it's a different problem altogether. The transpose of the rectangle is completely different problem to solve. But for square problem, for square matrix, it is very easy to solve like this. Simply exchanging the a of I comma j with a of j comma I. Okay. So if you look at the output, right? So that's what we did. 3 and 7. 3 and 7 will be replaced, and 8 and 6 will be replaced. And these three are same. I and j are same. 0, 0, 1, 1, and 2, 2. So they will be replaced with the same number, with the same place. So that's why they will be at the same location. Okay. Is it clear? Is it clear to everyone? Just give a thumbs up.
Yes.
Yeah. Cool. So it's very simple algorithm. I can share the code just as Arshad said. It's a very simple transpose. We will just have two uh, this is the print matrix, and here is the transpose. So we know what is the length. N is get length. Of course, I use C sharp just to give a heads up to you, Prabhu. I love C sharp. I use the C sharp for more than a decade. That's why I will give my solutions in C sharp. You can easily convert into any other language, and also
Yeah, yeah.
it's a basic
That's not
thing.
a problem.
Yeah, very few methods will change in the different languages, Java or even JavaScript or C sharp. These are very common. We will anyway. This is all the basic functions. We don't use deep functions or the complex functions of C sharp. That's not the main thing of algorithms. Is always like a just for loops and couple of basic concepts, right? Hash tables or those things. Stacks and queues, sometimes we will use stacks and queues data structures, sometimes we have to create our own. So but anyway, so this is C sharp. As Arshad said, simply a loop for columns, another loop for rows. I goes from 0 to n and j goes from 0 to m. Oh, interesting here, see, j is going only to the I. 0, 0. This is interesting here. So j we are not yeah, we should not okay, for 0 we are going 0 to 0, and for 1, if I is 1, okay, this is interesting to solve. So yeah, so let me say, let me explain the inner loop. The outer loop is easy. The outer loop is simply, you will say, how many rows. So I goes from, okay, so oopsie, let me select another color. So I goes from 0 to n minus 1, or number of rows, right? I goes from here 0 to n minus 1 for every row, right? For every row, like let's say we are doing I. So if we are I equal to 0, I equal to 0, we will just only exchanging this with the same value. But I equal to 1, if I equal to 1, we need to go all the way to j need to go from 0 to, if I equal to 1, it is going see, I equal to 1, it is going 0 to 0. J only going from 0 to 0 because it's less than I, right? So now we are exchanging. So j equal to 0. So so what happens, a of 1 comma 0 equal to a of 0 comma 1, 1 comma 0. This 2 will be replaced with 4, and 4 will be replaced with the 2. Now what happens is, that's it. We don't want to, so when you are taking this, right, we don't want to go to the third yet. The number 3 will be only taken when you start taking the 7, right? So that's why j we need to stop here. When the I is here, we need to stop j here. So I equal to 0, j less than I, j plus plus. So I equal to 0. The j equal to 0 here. So that's where we are exchanging the numbers. So now let's say I equal to 2. I equal to 2. Now j goes from 0 to 1. Right? So it will be replaced like this: a of 2 comma 0, right? So a of I comma j, I is 0, and let's say I is 2, right? When I is 2, 2 comma 0, 2 comma 0 means what number is that? 2 comma 0 is 7. Okay, will be replaced with a of 0 comma 2, which is 3, right? So 7 will be replaced with 3. Now j becomes 1. When j becomes 1, a of 2 comma 1, that means this one, 2 comma 1, replaced with a of 1 comma 2, that means 6, right? We don't want to do 2 comma 2. We don't want to do with 2 comma 2 here. That's why it will only go from here. So when you're taking, when I equal to 2, we will go only I minus 1. This is very important, right? So we are not going to take the all the columns. We will only take the columns until I minus 1. You get it? That is the main logic here. It's not like we will take every number and with every other number. We will only do until I minus 1 here, and then we'll do the transpose. Okay, is it clear to everybody, or any questions there?
Yes, clear.
Clear, Suresh.
Clear.
Nice, very nice. Okay, so it's easy kind of solution. Now let's go to the second one. Okay, second problem is print given matrix in diagonal fashion. This is interesting. Think of chasing them using arrows from left bottom towards the matrix. This is interesting problem to solve. So let me clear this, and I'm going to give you an example here. Yeah, here is the example square matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It will be like this. Let me draw again. So another matrix given: 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we are not exchanging, or we are not modifying the existing matrix. Our intention is to print in a different way. So we want to print in a diagonal fashion. So we no need to modify the existing given matrix. We want to print like this. Just go, it's kind of your, let's say you are here, you're standing here and putting the arrows. So the arrow will go on the first diagonal, and then second diagonal, and then third diagonal, and then fourth, and then fifth. So there are five arrows required. So it will be like you need to print just simply like this. In the first way, with the first arrow, 1 gone; with the second arrow, 4, 2; with the third arrow, 7, 5, 3, 8, 6, and 9. Just for every arrow,
Is it
whatever the
only
number.
for a square
No,
matrix or?
it should be, yeah, that's a very good question. So the given matrix, they said given matrix. Let's look at the um, algorithm. It says given matrix. It could be any matrix. Let's look at another example. So this is the output. You just need to print output in separate line. Basically every arrow, whatever the numbers or crash, you need to print those numbers in a separate line. So now let's look at the rectangle matrix. Very good question, Tarun. So here is a rectangle: 1, 2, 4, 5, 1, 2. Okay, so 1, 2, 4, 5, 1, 2. So here you can do the same thing, right? So it will be like 1 and 4, 2, and again 1, 5, and then 2, right? So it will be, it doesn't matter whether it is rectangle or square. We are not transposing. We are just you know putting the arrows, and whatever the diagonal, basically whatever the numbers we are touching in each diagonal, we are printing those numbers. And it could be same for this one also. Like even if it is rectangle like this, right, it will be like this, this. So how can we do this? Looks like tricky one, right? Any ideas or how to solve this problem? And
Suresh, if we observe, if we take the index positions of the each element, the
mm-hmm,
first line is 0, 0, so sum of that is 0.
mm-hmm.
Second line is 0, 1, and 1, 0, so that sum is 1. For
Sum.
7, 5, 3, it is 2, 0, 1, 1. Sum of the index positions, like
Oh,
sum of I and j.
you're taking the sum. Okay. Mm-hmm.
Uh,
Yeah.
I'm finding a pattern, like
Yeah.
for I, if you sum I and j, right,
Mm.
indexes of I and j.
Mm-hmm.
For 1, for 1 it is 0.
Yeah.
For 4 it is 1 comma 0, it is 1. For 2 it is 1, 0 comma 1, it is 1. For 7 it is 2 comma 0, it is 2. For 5 it is 1 comma 1, it is 2. I mean, that's a similarity. For rectangles also it is working.
Mm.
So I think we can,
So you're
we
saying
need
for
to,
let's do for seven and seven
that is
four.
also in an increasing order. That's also in an increasing order. First you'll print all zero sum, then 1, 2, 3, 4.
Mm.
In this though, maximum 4 only, because 2 comma 2 last 9. So yeah,
Very good, very good. It looks like an interesting problem. So basically, what you're saying is for each eight is like 2 comma 1, which is 3. For 6 also 1 plus 2, which is 3.
3,
And for 9, like next we are 2 plus 2, 4. So
2 comma 2, 4.
yeah, so it looks like it's a good solution. But in order to find the numbers with this, right? So first you are printing all the numbers with some 0, and now you are printing all the numbers with 1, isn't it? Right? Basically you want to scan the
Yeah,
array, and whenever you see if it, like you just say I equal to whatever 0 to n minus 1, you loop that, and the sum, basically I is sum. Whenever the sum equal to I, and you are taking those numbers. When I equal to 0, you will only get 1. When I equal to 1, you will get two numbers that satisfies this condition, isn't it? Right? So 4 and 2. And then when you say
uh,
I equal to 2,
I didn't.
yeah, go ahead.
I mean, still I didn't get how we'll implement, but I just saw a pattern.
Very good, very good. It's a
If the
good,
pattern is
it's a
I can
pattern.
see a pattern.
Yeah, you can see a pattern, and to implement this your solution, what you need to do, we need to create a for loop. I runs from 0 to n minus 1, which is sum 0, 1, 2, 3, 4.
Hmm.
Right? I think n, not n minus 1. It's like n plus n, because it's not, it should be, it should run from 0 to 4. 4 means n plus m, like n plus n, n plus n
Yeah,
minus 1. Then it will go
yeah,
0 to
maximum. Yeah, 0 to 2 2 2 times n minus 1.
yeah, that is also fine. Yeah, 2n minus 1. Yeah, 2n minus 1. Then it will go from 0 to 4.
2
No, actually 2
0 into 2 into n minus 1. 2n minus 2.
2n minus 2. Yeah, yeah, that's it. 2n minus 2. We need to put 2 there so that it will go from 0 to 4. Right? So,
Yep.
but anyway, so now
Yes.
you got the sum I equal to 1. Let's say I equal to 0, then you will scan all the numbers. Whenever the sum is 0, you are printing. When I equal to 1, you scan all the numbers, and whenever the sum is equal to 1, you are printing. Then now let's calculate uh, the algorithm. Then let's calculate the complexity of your algorithm. Okay, for every I, for every value
Okay.
of I, we are entire matrix you are scanning, isn't it? Because we don't know when we get the
Yeah.
one.
Yeah.
So you are scanning for every I, you are scanning 1, 2, 3, 4, 5, 6, 7, 8, 9. Whenever we will scan all the numbers. So order of n square for every time, order of n square, order of n square, right? So here how many times? It's a 2n into order of n square. isn't it? It goes 2n means 4,
Yeah.
right? So n is actually okay, 2n minus maybe 2 into n minus 1, because n is 3, 3 minus 1 2, 2 into 2 4, so 4 into order of n square. For every number you are scanning the entire array, which is
Hmm.
time complexity wise, it's not that inefficient, isn't it? It is a pattern, it is a
Y-
solution.
Yeah.
Yeah, I totally agree with you, but it is not the ideal solution, because it's taking a lot of time complexity. So is it clear to others like Venkat or Tarun, Prabhu? So the idea, it's a good
Yes.
algorithm. Yeah, it's like it's a one good solution. I don't say it's not a solution. It is a solution. It's a fine. It's good to find that pattern, but the thing is, it's not good in terms of time complexity. Okay. Now let's find another good pattern. Like how can we solve in a different way? So I'm going to give an example here, or try to explain. It is little tricky problem. Oh, I can't even erase easily. Okay, I'm trying. So what are we doing here is we need to navigate. It's all these array problems is we need to find a better way to navigate. In the last problem, we find a better way to navigate, right? In the transpose, we navigated not diagonally. At least we'll find how much we need to navigate for j. That is very important, right? Similarly, here we need to find a better way to navigate. It is another way of navigation. So normally, if I to print the matrix, what we do? If I ask you to print exactly the same way, what we do? We'll have two for loops. We will navigate the numbers, right? It is also just printing the numbers, but in a different fashion. We are also printing the numbers, right? So let me show you the normal printing. You guys already know this. So if I want to print the matrix, here is the printing algorithm. Where is here? Printing algorithm. Very simple. What we do is we'll take the n number of rows and then number of columns. We will have two for loops. I goes from each column. For each row. For each row, we are navigating the entire column, isn't it? So basically, this for loop, you are simply releasing the arrows this way, isn't it? You are simply releasing the arrows this way and you are printing 1, 2, 3, new line, 4, 5, 6, new line, 7, 8, 9, new line, isn't it? Look at here. I am putting a right line. What happens is once you complete a column, we are printing a new line, and then let's take the next row and you are completely printing that column, isn't it? So we are simply at this norm in the normal printing, we are releasing the arrows in a horizontal way, isn't it? Now we want to release the arrows in a diagonal way. So it's just another way of printing the numbers, navigating the numbers in a different direction. So it's not like horizontally, it's diagonally, right? But if you carefully understand, we can find the solution. So you guys understood this algorithm, right? How we are printing, right? we are taking
Yes.
we are taking each row and printing. Now here also we are taking each row. Carefully observe here. I'm trying to explain here. Now first, initially you will start with 0th row. This is rows, right? This is rows. So now you are starting from the first row, you are starting from the third row. So simply you can have I equal to 0 to, let's say this is, and this is m. Okay, it's because it is rectangle, we need to solve for rectangle also. So I goes from 0 to n minus 1, 0 to, so for every I we need to navigate in a diagonal fashion. So j is not simply 0 to m minus 1. If we say 0 to m minus 1, it will be horizontal. You are always, taking first column, second column, third column, first, second, third. We don't want to take all the columns. That is the catch here. If you are taking 0, right, if you are starting from the first row, we are going all the way to 0. Look at that logic here. If you started from 1, only column going 0 and 1. If you started at 2, we are doing, let's look at here. For 2, where are we starting? Yeah, we are starting at 0, we are printing 7, and then 1, we are printing 5, and then 2 and 3, basically this. So for 2, we are going all the way to 2, right? But here we need to print diagonally. That means carefully observe how the loops are going. Okay, so now here, if you start from here, let's say, yeah, this is better. If you start 4 2, right, if you start 4 2, right, your I equal to 0, I equal to 1, I equal to 1, right, second row. But now, in addition to that, if I equal to 1 means you're attacking second row, you're attacking second row. But now navigation is different. This is attacking, basically this particular loop will tell you, hey, attack the first row, attack the second row, right? Now the navigation is different, so we may need two different loops. Okay, what I'm trying to say here is, you will attack the, oh, my lights is just blinking. I don't know if I get the power loss, I may disconnect anytime. Just giving you heads up. I'm just looking the flickering in the power here. So we are attacking in a diagonal fashion. That means, so let me show you. So 4 2. Okay, let's write down the indexes of 4 2. Indexes of 4 is 1 comma 1. Index of 2 is 0 comma 1. Okay, so now I equal to 1, I equal to 1, we are attacking the second row. This is, let's say, sorry, let me give you k. Let's take this as k. Let me see the actual integers for the sake of easy understanding. I want to use the exact same variables. Yes, k. Yes. So this is k. K is basically will tell you the arrows. For k equal to I means we are attacking the arrow on the from the 0th row. If k equal to 1, that means we are attacking the arrows from the second row. If k equal to 2 means we are attacking the arrows from the third row. Okay, k represents the starting point. Okay, now I and j. Let's take I and j. Now let's look at I, from where it is going. I started at k, because you need to start at that row, right? I started at k. Now look at this, you are going in it this direction. This direction means you attack at this line, next this line, this line, this line. So I is decreasing, isn't it? Carefully look at that. Row you are decreasing when you are attack a arrow like this. So the row is decreasing, but column is increasing, isn't it? First column, second column, third column. That is the logic here. You guys understood? Basically, that's where we are navigating. We are navigating in this direction. These are the elements we are attacking. What is the main property here? This one, basically I is decreasing. That means row is decreasing, but column is increasing. You guys got the idea here? Give a thumbs up if you're following.
No.
Okay, let me explain. So we are going to attack the numbers in a diagonal fashion. I got some thumbs up from someone. I don't know who is that. But anyway, that's good. So basically, I'm trying to explain. So we are attacking the numbers in a diagonal fashion. That means this is the crux of the entire logic. So when you are attacking the numbers in diagonal fashion, what that means is, we need to, let's say it's a big matrix. It's a very big matrix, and here are the numbers you are attacking. Okay. So you started here. Okay, now you are going little bit up. That means you are going to the previous row, isn't it? You are going to the previous row, At the same time you are going to the next column. So the so the row is decreasing, column is increasing. That's what the diagonal means, right? What is the diagonal? Basically, if you want to go to the top one, you need to decrement the row and increment the column. That's the
Yeah.
upward diagonal. Again, you're
Yeah,
done with this.
got it.
Now again you decrement the row, you are decrementing the row which is previous row, but incrementing the column, right? That's how we are printing.
Yes.
Just that is the main problem. That is the main thing here in the normal printing. What are we doing here in the normal printing? We are just stuck to one row, always like row number 0, but j goes from 0 1 2. Basically we are incrementing only the column. In the horizontal, what we do is we don't increment the row, but we will increment the column. Print this number, this number, this number. So the j is incrementing, but I is not incrementing or decrementing. I is constant. Let's say you want to display, column wise. You want to display 1 4 7 and 2 5 8 3 6 9. It's very simple. We want to display the numbers in the column wise. What we do is we will make the j constant, and then we'll print like this. That means I, we are incrementing I, and j is constant. Here we are not incrementing the column, we are only incrementing the row. That's why we got 147, isn't it? So but here we are going diagonal. Diagonal, when you say diagonal, either any diagonal shape, we have to increment and decrement each indexes at every step. That's what I'm trying to explain here. So basically, now you understood, right? Once you display this number, you have to decrement the I and increment the j. Display this number and decrement the I, increment the j. Display this number and decrement the I and increment the j. Now display this number. But here is the problem here. Until how long you go? You decrementing, but you need to, there should be a stopping condition, right? I needs to go. You started at k, you started the arrow at this location. There will be another numbers down the line, but you released the arrow. That arrow started, I started from k. So from k it will go to k minus 1, k minus 2, all the way to, what is the stopping condition? When I becomes, when we stop. So for,
At the end of the first,
exactly. See, look at the 4 too. 4, we printed 4, and then we print 2, then we stopped there. Why we stopped? Because there is no more numbers on top of 2, right? 2 is at the top of the matrix. That means I, when I becomes, when we stopped, when I becomes,
When I will become 0 or j will increase, like j will reach the end.
exactly. Anything is fine.
Both
Either,
for for 8.
yeah, we'll come to that 8 and 6 situation. I'm always talking at 4 2 right now. Just put your eyes on the 4 2. We started at 4, and then we are going in a diagonal
And I
fashion.
become 0.
When I becomes 0, that means you reached the top of the matrix. You stop. You cannot print anything out of the matrix, right? See, after 4 and 2 you need to print something here, but there is nothing here. This is the starting point. That means whenever you start I equal to k, the k should go all the way to, from k to 0. You are going diagonally, it will go all the way to the top, right? 4 2, again 7 5 3, 3 at 3 we stopped, right? You look at the I, just from the perspective of I. So if k equal to 2, if k equal to 2, you start from I start from k all the way to 0. If I becomes less than 0, stop. You don't want to print anything. That's kind of, loop. Basically you need to start, it's kind of a reverse way. It's not a for loop, because you need to decrement. It's kind of while loop. You can also put a while loop. You can write for loop also, it's not a problem. Now let's look at that. When you are decrementing I, What about J? Where to start J, where to start J, and where to end J? So for 4 2, what is the column you started? For every row, for every arrow, you are starting at the that particular arrow's location. If your second arrow, right, if k equal to 1, you are starting at one throw. If k equal to 2, you are starting at the two throw. But which column you starting? You always start with
I plus 1. I mean k. J is
k.
equal to k plus 1, right?
Do you
K
think k
plus
plus
1.
1? Because you always start you are releasing the arrow always hit the first column number, the number on the first column, isn't it?
Okay.
In it, just only consider until 7. Don't consider 8, 6, or 9. There's a different logic for that, because when you release arrow first time, 1 will be touched, and then when you release arrow second time, 4 will be touched. When you release arrow k equal to 2, 7 will be touched, right? That means first column, isn't it? For simplicity, just forget about 8, 6, 9. Okay, you are attacking each row. You attacked row number 0, column number 0. Attacked 1, row number 1, column number 0. Attacked 2, row number 2, column number 0. So what is constant here? You are always starting with column number
0.
0. That means j equal to 0. So for this iteration, we'll start with 0. Now until which until what until what column you go? In the first row, in the first go, when k equal to 0, right, you attack number 1 here. You attack number 1, but you did not attack 2 or 3. For the arrow is just going up, arrow going up, and you did not attack 2 or 3, so we no need to go 2 or 3 in that situation. But if you go with 1, you attack the arrow number 1, so you attacked 4 and then 2. That means it will go only two columns. So j is 0 and j is 1. So when k equal to 1, j goes from 0 to 1. When k equal to 2, j is going from 0 to 2, isn't it? Check that logic here. So 0 is basically you are I just explained, we need to decrement k. That is fine, but how long we need to increment the j? That is what we are figuring out now. We already figured out how to decrement until what stage we need to decrement, but we need to increment. How long we need to increment? All the way to 2, all the way to k. We don't want to decrement all the way, all columns all the times, right? So when you start here, this is the column ending. When you start here, it will go here and stop here. We no need to go all the way to the next columns. That is what it is. So j runs from 0th column to k until k. Let me double check the logic. Actually, it is tricky. I know this logic is tricky. Yeah, see that? I think okay, I think this is the one. J is less than columns. Calls. What is calls? Oh, actually, oh, okay. You can also put like that. You can also put, you can, so there is no need to restrict with k. You can put all the way to the columns. But the thing is, whenever you go this direction, this will hit it. You never, like when you print 4 and 2, right? You already hit the first column, first row. So it will be ended. So simply you can also go from I 0 to 2 all the times. I 0 to 2. J, sorry, J. J you can put 0 to 2. It doesn't matter. You always, tackling all the columns with one. You try to tackle one first column, second column, third column, but once you attacked one, it reached I becomes -1, it will stop. Again, when you start with 4, so the k the I try to decrement from 1 to 0, 0 to -1. So again, that will be gone. Similarly, if j equal to 0 means, just sorry, k equal to 2 means So you start with 2, I becomes 2, I becomes 1, I becomes 0. At the same time, j becomes 0, 1, 2. So the I decrementing and j incrementing all the way to 2. Okay. So this whole loop will print the numbers like this. The until now we wrote a loop by using k, by using I and j, we printed like this. We print 1, we print 4, 2, we print 7, 5, 3. Okay. Now we need to print 6 and 8, 6 and 9. So this loop will not print it because you are starting only on the rows. You attacked row number 0, row number 1, row number 2, then you're done. You're done. But that's not the final output, right? Now you need to attack bottom columns. That is what the logic here. Remaining bottom columns, last column, basically bottom column in the sense, because until now we attacked on until this diagonal, we attacked only half of the matrix, right? You are standing in here, you attacked 3 rows, done. Now you need to attack the columns, remaining columns. That will make the entire column to fulfill, entire matrix to fulfill, isn't it? You understood what we are trying to do here? So you completed first
Yes.
diagonal. You completed first half of the matrix with this logic, with this whole logic here using k. You started. You attacked the first row, second row, third row, but the third row will go in a diagonal fashion, and the middle numbers will be attacked, but remaining numbers will not be completed. We don't know how many, right? That's where we need to attack the numbers from the bottom column, but we no need to start from the first column, because as part of the 2, you already attacked this, right? So now again, k need to start from 1. You need to attack the column number, like a bottom row here. You need to attack the columns, basically attack this column number 1, attack the column number 2, and go from there, right? So the logic here, if k equal to 1,
Yes.
if k equal to 1, I equal to same thing. I now, initially we started at k, right? It is a tricky logic. We need to say n minus 1 minus k, I think that's the logic here. So because we need to find out where to start. Yeah, see, rows minus I, oh wait, rows minus 1, huh? Yes, rows minus 1, j equal to k, changing the numbers along the columns from the bottom. Okay, so we started at k equal to 1. As I said, we need to start from 1. So we need to start attacking from 8, right? Which is 1. We already attacked the diagonal. So you need to start from 1, 2, 3, 4. How many columns? We don't know. So now we started with 1. Now let's see. I equal to row minus 1. I equal to row minus 1, which is, again, we started with the same. We started with the last row. I equal to row minus 1. So initially, yeah, it's the same thing, row minus 1, and j equal to k. Why j equal to k? Because we need to start from that column. We need to start from this column. We need to start this column. So j increment from here, and I decrement from here. Okay, so that's the condition here, simple condition. If as long as I greater than 0 and j less than columns, so that's the same condition here and here, same condition. As long as you are inside the boundary, basically I greater than 0 means you are still in the matrix. Similarly, j less than columns means you are still in the matrix. As long as I and j are within the matrix, print I and j. Same logic, I minus minus, j plus plus, decrement I, increment j. It's the same logic, right? You only difference here is the value of k. Here you started attacking the rows. Here you started attacking columns. Is it clear? So the first for loop will attack all the numbers until diagonal. Now here you no need to start from the diagonal. That's why k equal to 1. Now k equal to 1, that means you start from the second column and until last column, right? So you attacking the numbers from the first column all the way to the last column of the array. I know it is difficult to understand at the first row, like in the first go, but I'm trying to explain my best how we are attacking and how we are navigating. Is it clear, or should I explain again, or is it difficult?
Suresh, one quick thing.
Yeah.
So the first thing is like what we are trying to do is we are trying to go with the diagonal, the middle diagonal first.
No, not
From
the
there,
middle diagonal. We are starting only from the first, right? We are starting from the top of
yeah,
the,
no, no, no.
yeah.
We are getting the values like just printing from the first, but we are capturing the date. I mean, the ith and k values and j values from the middle diagonal. So
Yes.
that what is the k value, what is the I value, what would be the j, I mean j value, right? So
Yes.
then we are always decrementing the uh,
I
rows and incrementing the
columns.
columns,
Yes.
right?
Yes.
And all the way go to the first position of the that one, and I'll print. Then next again we'll print 4 2, then next we will print 7 5.
3,
What is that? 7
5
7
3,
5 3.
7 5 3.
That is the one complete one whole block.
Yes.
Then what we are trying to do is now we have to go with the diagonal below portion of the elements.
Exactly. Exactly.
So 8 6 9. So that
Yes.
one we have to print. So how do we print? We have to since we have already printed till 753 from 1 to 753.
So yeah.
Now we are trying to decrement. We incremented the k value, the
Yes.
second block, and we were trying to the position, the logic whatever we have written there, the same way
Yep.
downwards like
Yes.
8 6 and 9. Okay,
Yeah. It's the same thing. Basically, you can see chasing the numbers along the rows from the left side. See this by commenting,
correct.
we can try to understand. We are chasing the numbers along the rows. How many rows we have? 0 to rows. Row, it will go k all the way to go to 0 to 2, isn't it?
Yeah.
Now, changing the numbers along the columns from the bottom. From the bottom. That's why, so k equal to 1. We no need to start from k equal to 0. If you start k equal to 0, we will print diagonal 2 times, isn't it? Again, you start from 7 5 9. 7 5 3 will be printed another time. We don't want to
Yeah.
print 7 5 3 second time, right? So we are starting from the second column, which is k equal to 1, right? K equal to 1. But how long you have to go? We don't know how many columns, like k less than equal to columns. So if you have another like 10 columns, we will attack all those columns. That's why it is diagonal. If you start here, right, you will keep on attacking these columns. We don't care. Only 0 1. Like I will always go from this and this and this one, this. Like basically it will decrement, and then you attack the numbers in the diagonal way until you finish all the columns, isn't it?
Okay.
Yeah. Is it clear, Tarun or Prabhu?
Yes, Rish.
Very good, very good. Yeah. So it is tricky question. I know. I don't. If I am the interviewer, I don't ask this question at all because there is no much, thing that we can get out of the candidate because it's a it's a way to navigate and put the for loops in such a way to print the numbers. There is no, you know, uh, you know it's not a tricky thing. It's not like you are using some hash tables or something like that, or we can have there is no way we can have a greater discussion here. Hey, I can say, hey, why you did this, why you did that. I cannot ask anything because you are just manipulating the indexes, right? So if I'm personally, I don't ask this kind of questions, but there are situations, there are companies and interviewers, they will ask this kind of questions, but we need to understand how to navigate. That's it. There are other questions also, like print the matrix in a spiral way. So you start from the middle, you print like this, and you print in different way. It's a tricky questions. There are a lot of tricky questions. All these questions are it's a matter of manipulating the numbers. Okay, manipulating the indexes. Where what is the main pattern happening, and how to manipulate that, how to create the loops to mimic that pattern, right? Any questions, Tarun or Prabhu or Arshad? Are we clear on this one? I can show the algorithm here.
Clear, Suresh.
Tarun, any questions?
No, it's clear, Suresh.
Yeah.
You can go.
So I can also like show with the breakpoints, but it is the same thing. You can also run yourself. Okay. So basically, I took the different inputs. And if you write this kind of logic, the only thing interviewer will look at is how many types of inputs you take. So for the first one, right, this is the for the transpose, I took the simple 3 by 3 matrix. For the second question, I took three matrices. First one is, this is 3 by 3, and the next one is rectangle matrix 1, which is 1 2 4 5 1 2. So, and rectangle matrix 2, which is like two rows and three columns, 1 2 3 4 5 6. Okay. So here is the transpose for the first one, and now rest of the matrix is just printing the diagonally. So I printed matrix 2 diagonally, rectangle matrix 1, rectangle matrix 2 diagonally. So here is the spiral printing of matrix is also there. It's there in my GitHub. So I will share this if you're really interested. It is again another complexity, like it's little bit complex than what we just discussed. Spiral means like it should start from something like this. It should print like this. So numbers need to print. You start from here. Basically, for the given input 1, 2, 3, and then 6, 6, 9, 8, 7, 4, 5. So it's spiral. You're going in spiral fashion. So how to print that? If I'm going to give you a big you know big matrix, it should be, I think the spiral should be only for square matrix, or maybe, yeah, only for square matrix. You will go this direction until you reach the middle point. Okay. So that is also complex logic involved in that, but I'm going to show you the output here. So here is the before transpose. Here is a 1 2 3 4 5 6. After transpose, it is 1 4 7 2 5 8 and 2 3 6 9. That's the first question. And now here is the diagonal printing. Right, for this one, 1 2 3 4 5, we discussed 1 4 2 7 5 3 8 6 and 9. That's a diagonal. For rectangle, right, for this rectangle, what will be the output? 1 4 2 1 5 and then 2. So all these, like, look at this. These three rows, the first three rows will be covered in the first loop itself, isn't it? This will take care. We are changing the numbers from rows of using the rows along the rows from the left side. So if you change the numbers 1 4 2 1 5, all those numbers will be chased from the left side arrows. The only thing pending is 2. That will be taken care by the second for loop. You started at k, and then it will go k equal to 1, right? So then it will start from there. So now here, look at the rectangle matrix 2. Here 1 2 3 4 5 6, right? Now 1 4 2. That's it. 1 and 4 2 will be tackled by the first for loop. Look at that. I would say, take this algorithm, convert to whatever language you want, JavaScript or Java, whatever. Put the breakpoints and understand how the algorithm is going, from where k is going from where to where. So I already put the breakpoints here. You can also put the breakpoints and try to understand. You can also comment the second for loop, comment it and see the output. So it will print only until 4 2. That's it. Because you're attacking the row wise. You attack the first row, you attack the second row, you're done. Now the second for loop will take care from the first column. First column is 5, 5 3, and then 6. 5 3 and 6 will be printed by the second for loop. Okay, that is the problems we are going to discuss today. Any questions or any feedback? Is it clear, or am I going speed, or am I going slow? Give me any feedback. Tarun, go
No,
ahead.
Suresh, it's good.
This
You're going
question,
correct.
Good.
Nice. Yeah. Tarun, are we clear?
Yes, Suresh, it's
Very
clear.
good. Very good. Yeah.
Like
Yeah. Go ahead.
this problem, while you're saying, like we need to visualize and
Yep.
yeah, it will be more comfort while practicing.
Definitely, yeah. It will only comes with practice, like only visualization. How can we visualize? How can we navigate? I really like the Arshad. That's a good idea. It's innovative idea. Like I that's another solution, another solution to the problem. But only complexity wise. Now look at the complexity of this algorithm. Now we completed the this part, the algorithm part. Let's compare the complexity of this algorithm with the Arshad, the initial algorithm. So, what is the complexity of this algorithm? It looks like so many loops. We have for loop here, while loop here, and then while loop here. Look at the and condition here. It's like we need to do this, and as long as you're inside the matrix, it's like it's and condition because I should be greater than 0 and j should be less than columns. So you are going in a diagonal direction, right? When you are going in a diagonal, right? So you start from somewhere, you start maybe second row, third row, you will go minus 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 I minus minus until I equal to 0. That's it. At the same time, columns you should not go beyond the columns, right? So this is the while condition we are doing because of the two indices. We are going in a two pointer approach kind of thing. Okay. So, what will be the time complexity? Anyone? Harshad?
maximum order of n square only, Suresh.
It's
Also.
n by m. Like basically, it's not matrix.
Okay,
Yeah,
if it's okay, n by m, yeah.
yeah. Order of basically we are only navigating numbers only once. So n by m time complexity. We are not navigating multiple times, but in the algorithm you initially said if you get sum equal to 1, sum equal to 2, we don't know where that sum comes, right? You need to navigate you know every number and compare with the sum. But here we know the actual pattern, right? We are not navigating any number more than once, isn't it? So that's why it is order of n into m, which is every number will be touched only once. So is it clear, Tarun and others, Prabhu or Venkat?
Yes, it's clear, Suresh.
Nice, yeah. And the space complexity, I think it's anyone can guess space complexity. Order of
Order of one.
NM only, I think.
nm. Do you think nm? Are we taking another
Uh,
another matrix?
Here, constant, right? We are only using temporary variables.
Exactly.
Constant O of one.
Yes,
Yeah,
O of
order of
one.
one. We are
yes,
hardly way to two, three,
correct.
four, five variables at any point of time, right? So it's a constant. Just always time complexity. Think space complexity. Always think about how many variables we used, and and also is it incrementing proportionate to the input? That's always the second consideration. So space complexity. So here are we incrementing? If I'm giving you 10 by 10, are we taking another 10 variables? No, right? It doesn't matter. It's 10 by 10, 20 by 30, or 100 by 100, 100 by 200. I don't care the size of the matrix. I'm always taking hardly 5 6 variables. It's a constant space. I need just a small MB or couple of, let's say 3M. Let's assume that this particular algorithm taking 2 KB. I just need the 2 KB of space to run this algorithm. I don't need any additional space. That's why it's a constant space. So irrespective of the input, I just need that 2 KB. Give me 2 KB of space and is RAM which can run this problem. That's it. I can solve the problem. So there is no additional space required for additional data based on the input, right? That's why it is it's not spans, it's space, SPSE. Yeah, space complexity is order of one. Is it clear, Venkat and Prabhu?
Yes.
Yeah,
Yeah, that's good. Nice to know that. Awesome. I think it's almost like 9, which is like 10:30 in India. So let me share this this code. I will share the code link, and also I will share the recording. I hope it is helpful. So we have one more, I think, is, oh, this is the rotate matrix. Yeah, is it done yet? Oh, okay, this is the one which is pending. We can do this. We can also have more problems on matrices. We have so many problems in Geek for Geeks. So if you want, we can try that. So there is one more, I think we discussed it last time, like last year, pair with largest sum which is less than k in the array. Oh my god, there's another problem. There is tons of problems. So we can practice these if required, and then we will go to the strings in couple of weeks, maybe in next week or next to next week, like string palindrome, unique permutations, and URL encoding, and string path matrix, substring. There are a lot of reduced string, convert to lowercase. There are a lot of, we always use these functions in C sharp, right? Two lower, two upper. But how it will do, text trimming is there, reverse the word, reverse the given word, how to reverse the word. There are a lot of things we can do in the strings as well. So some of the interviews you will get string problems, so we can discuss in the coming weeks. So okay, until then, just practice these arrays then. Any questions?
Thank you, Suresh. Thank you so much for your time. I think
No
we
problem.
are good. Uh, we need to do any extra practice. I think that is.
Yeah, just
Uh,
I would say, if you, since you are not superly attending the interviews, what I say, just look at the problem one more time, the solution one more time, just 10 15 minutes or something like that, or just look at the understand the different patterns. That's it. Whenever you practice next year, or then you will be able to recollect, right? But for the people who are attending the interviews, I will say spend extra time to practice with the pen and paper. Once you understood, just close everything, close all the laptops, take pen and paper, and try to practice. Okay,
yeah, sure.
awesome. Thank you, everyone. So talk to you next week then. Bye, Tarun.
Thank you.
Bye, Ankit.
Thank
Thank
you.
you, Suresh.
Thank
Have
you,
a nice day.
Suresh. Bye.
Bye. Bye.